Hi everyone, how are you doing? I hope you're all fine. I hope you're all geared up to study chemistry, and here we go into analytical chemistry. Okay, what's analysis? Analytical means to analyze a compound. And how do you analyze in the first place? You analyze it by the color of the salt. Okay, when you see a person walking at a distance, the way they walk, you can identify or recognize the person. Just like that, by the color of the salt, you can identify the salt to a certain extent. There are some colored salts, okay, and there are colors due to the cations and there are colors due to the anions too. Now when you come to the cations, one thing we should remember is there are some groups which are totally white in color or colorless. That is group 1, 2 and 13 to 17 are normally colorless or white. Colorless we mean as a solution. When you add water to it, it becomes a colorless solution. Otherwise it is actually, they are white solids. Okay, when you come to others, say copper ion, any copper salt would be bluish green in color. Okay, then there are a few green colored compounds, like you have chromium ion, which also gives a green color. Nickel also gives a green color. Of course, ferrous also gives a green color. So these are cations which are all green in color. Then you have something like cobalt, which can be blue and pink in the hydrated form, and in the unhydrated form it changes the color, but cobalt is pink. And then you have manganese, which is pink in color. So these are the colors that we need to remember as far as cations are concerned. Okay, when you come to anions, most of the anions do not have any color, but there is something like permanganate MnO4 minus, which is pink in color, just like grape juice. You get a pink or violet color for permanganate. Similarly, dichromate, this is dichromate, this is permanganate. Okay, this dichromate also gives you orange color. Other than this, all others give a colorless solution, which means, like let us take chlorides or bromides, sulfites, sulfates, carbonates, nitrates, and so on. All others would be colorless. Now we move on into the next step of analysis. We are going to use sodium hydroxide and ammonium hydroxide, and we are going to see the different colored precipitates that we are going to get when they are added in just a little and then in excess. Here we go. Now we move on to the reaction of salts with two reagents. Okay, one is NaOH or sodium hydroxide solution, and the other one is ammonium hydroxide solution. So both of them give different colored precipitates with different ions. Okay, so when we start off, let us start with, say, calcium nitrate. Okay, now for this we can make use of this chart, which actually shows us different colored precipitates with NaOH, this is the inner round, and NH4OH is the outer round. Okay, now when you take calcium nitrate with NaOH, there is a white colored insoluble precipitate, precipitate insoluble in excess. Okay, from now on we will be looking into this very often. Alright, so when you come to this, you get a white color precipitate with NaOH. Basically, these reactions are double decomposition reactions. That means what? you are breaking down. Decomposition means to break down. Double means two compounds. So these two compounds are broken down and the radicals are interchanged. Okay, actually what do? You break it down and you interchange the radicals. Okay, so what do you get? You get a precipitate of calcium hydroxide plus what is left out? Sodium nitrate. Okay, now this is 2 here, so if you put 2 here and 2 NaNO3, then it is balanced. So this is a white precipitate which is insoluble in excess. Okay, so that's about with NaOH. Same calcium nitrate is not able to form precipitate with NH4OH because no reaction or no precipitate is formed. PPT means precipitate. Why? Because the concentration of OH ions is very less. Hydroxyl ions is very less, therefore does not form any precipitate with calcium nitrate and NH4OH, whereas the same calcium nitrate forms a precipitate with sodium hydroxide. Okay, next we move on to magnesium chloride. Now this gives a dull white precipitate with sodium hydroxide. Again, you break the compound into two. Now sodium and chlorine will come together. So you get magnesium hydroxide precipitate plus sodium chloride. Now there are two chlorine atoms. Therefore, we add 2 here. In that case, 2 NaOH. This gives you a dull white precipitate which is again insoluble in excess. Okay. The same thing happens with ammonium hydroxide. It gives the same dull white precipitate of magnesium hydroxide plus what else is left there? Ammonium and chloride combines to give you ammonium chloride. So 2 here and 2 molecules of ammonium hydroxide. This also is a dull white precipitate. Okay, so that's over. Now we move on to ferrous sulphate. What happens to ferrous sulphate? This ferrous sulphate also reacts with sodium hydroxide to give, again you break it down like this. So what is possible? Sodium and sulphate combines to give you sodium sulphate. Ferrous hydroxide, so FeOH twice plus NaSO4. Sodium's valency is 1, sulphate is 2. So when you crisscross, you get Na2SO4. Okay. Now this is the formula. 2 sodium atoms, therefore 2 NaOH, and then it is fine. Okay. This is a dirty green precipitate, again insoluble in excess. When you add excess of sodium hydroxide, it is still insoluble. Still the green precipitate is retained. Now let us do the same thing with ferrous sulphate and ammonium hydroxide. This also gives you a dirty green iron 2 hydroxide precipitate. Why do I say iron 2 hydroxide? Because ferrous is, the valency of ferrous is 2. Okay. Plus ammonium sulphate. Now the sulphate valency is 2 and this is 1. So when you crisscross, you get NH4 twice, SO4. In which case, if we have 2 NH4OH, then it is correct. So this is what happens with ferrous sulphate. Let me show you what happens with ferrous sulphate and let us first see ferrous sulphate. This is ferrous sulphate solution. If I take NaOH solution here, you get a dirty green precipitate. Okay. Now the same thing, if I am going to take ferrous sulphate and if I am going to add ammonium hydroxide to this also gives you a dirty green precipitate. See, both are the same dirty green precipitate and they are insoluble in excess. So this is what happens with ferrous sulphate and ammonium hydroxide and sodium hydroxide. Next we move on to ferric chloride. This is Fe3 chloride and this is a highly deliquescent substance. This we need to remember, this is a deliquescent substance. Okay, so what will happen? It will absorb moisture and become a liquid very easily. Okay, this ferric chloride combines with sodium hydroxide, again undergoing a double decomposition reaction like this. So you get FeOH thrice, which again is a precipitate, plus sodium chloride. Okay, 3, so 3 here and 3 OH, so 3 NaOH. Now this is a reddish brown precipitate which again is insoluble in excess. Okay, alright. Now the same ferric chloride, when it reacts with ammonium hydroxide, also you break down. Here we get sodium chloride, here we would get ammonium chloride, but the precipitate is ferric hydroxide. Again it is a reddish brown precipitate and it's insoluble in excess. Okay, and along with this you would get ammonium chloride. 3 here, so 3 molecules of ammonium chloride and 3 NH4OH. So this one, let us do it with NaOH as well as, let us take ferric chloride. This is ferric chloride solution, which means I have added water to it and prepared a solution. Now when we add sodium hydroxide to it, you get a reddish brown precipitate. Okay, so you are getting a reddish brown precipitate with sodium hydroxide. Let us try the same thing with ammonium hydroxide. I am taking ferric chloride again, and to this when we add ammonium hydroxide, again you get a reddish brown precipitate. When I add it in excess also, the precipitate continues to stay. So in excess both NaOH and NH4OH are giving the same reddish brown precipitate. Next we move on to lead nitrate. This is a white colored salt and we must remember this is the only soluble salt of lead. Okay, that is a speciality. That is how we can form a solution with this lead nitrate. Again reacting with sodium hydroxide, it gives, again you break it down this way. So you get lead hydroxide precipitate, this is chalky white, and what is left out is sodium nitrate. Okay, 2 here, so another 2 here. So this is chalky white, but the thing is, in excess it is soluble. So that is the difference. So far what we saw was insoluble, that means the precipitate continued, but in this case it is a chalky white precipitate which is soluble. But when we come to ammonium hydroxide, lead nitrate solution reacts with ammonium hydroxide solution to give, again it breaks down like this, to give you lead hydroxide precipitate plus ammonium nitrate. Okay, 2 here and 2 here. This also is chalky white precipitate, and in excess also it is insoluble. So there is a difference between NaOH and NH4OH with lead nitrate. Now let us see that. Let us take with NaOH, let us add lead nitrate solution. This is lead nitrate solution, and we take NaOH, gives a chalky white precipitate. Now as I add some more, now slowly it would dissolve the precipitate. This is the chalky white precipitate. Let me take a little bit of this chalky white precipitate, and if we add excess of sodium hydroxide, you can see that the precipitate clearly dissolves and it forms a colorless solution. This is what happens with sodium hydroxide. Now moving on to ammonium hydroxide, let us take lead nitrate solution. I have taken lead nitrate solution, and I am going to add ammonium hydroxide to this. You get a chalky white precipitate. If I add it in excess also, the precipitate still continues. Even though it's added in excess, it's still chalky white precipitate. So that is the difference between sodium hydroxide and ammonium hydroxide with lead nitrate. Next we move on to the next salt, that is zinc sulphate. Okay, this again reacts with NaOH to form zinc hydroxide plus Na2SO4, that is sodium sulphate. Now this zinc hydroxide is a gelatinous white precipitate. Okay, but what happens is, this is soluble in excess to form a colorless solution. So that also we have to look into. Similarly, when we take zinc sulphate plus ammonium hydroxide, we haven't balanced this, right? So 2 here, so 2 NaOH and Na2SO4, it's correct. Now when you come to ammonium hydroxide, again it breaks down like this to give you zinc hydroxide, which is again a gelatinous white precipitate, and this also is soluble in excess, plus what is left out is ammonium sulphate. This is divalent and this is monovalent, therefore the formula becomes NH4 twice SO4, so 2 here and zinc hydroxide is 2. Okay, so what happens actually is this will react to give a colorless solution. Okay, so this zinc sulphate plus excess of NaOH would give you sodium zincate. This is divalent, this is monovalent, therefore Na2ZnO2 plus water. Okay, 2 here and 2 here. This is a sodium zincate, which is a colorless solution. And remember, the word solution is very important because this is a precipitate that is formed and this dissolves to give you a colorless solution. Now let's move on to this side. When you take ammonium hydroxide, this also reacts with zinc hydroxide further. A little more of ammonium hydroxide is added. This also gives a colorless solution. It dissolves, but you get tetraamine. Okay, tetra is for zinc sulphate plus water. Okay, this compound is called tetraamine zinc sulphate and it is a colorless solution. So both are colorless, but the compound formed is different in both the cases. So 2 here, tetra, and water becomes, so 4 here. Yeah. So this is what happens with zinc. Let us see what happens here. Now let me add zinc sulphate, and to this I am going to add sodium hydroxide. It forms a gelatinous white precipitate. Now when I add it in excess, this precipitate starts dissolving, and see, you can see slowly the precipitate dissolves on the top. If we could take just a little bit of this gelatinous kind, and if I add excess the solution, this precipitate dissolves almost and becomes colorless. Okay, this is about zinc. Next we move on to copper sulphate. Oh, I didn't show you ammonium hydroxide. So we should see zinc with ammonium hydroxide. Let us take zinc sulphate solution and add ammonium hydroxide to it. You get a gelatinous white precipitate, and when excess of ammonium hydroxide is added to it, the precipitate starts dissolving. You can see the dissolving precipitate and a clear solution. The whole thing will become clear later. Okay, that is about ammonium hydroxide. Next we move on to copper sulphate. Okay, when you come to copper sulphate again, there is something different. With sodium hydroxide, again a double decomposition reaction. So it splits this way to give copper hydroxide, which is a pale blue precipitate. Pale blue precipitate, but insoluble in excess, which means the precipitate continues to stay as such. It does not dissolve. What is left out is sodium sulphate. Okay, so 2 here, then it is correct. This side with ammonium hydroxide, it reacts to give you copper hydroxide, which is again a pale blue precipitate, and ammonium sulphate. Okay, this is a pale blue precipitate, but the difference is this is soluble in excess. So this is soluble in excess. And what does it form? Let us see that now. Let us take the copper hydroxide plus this ammonium sulphate mixture. Add a little more ammonium hydroxide to it. This gives you a complex salt, tetraamine. Again, tetra, copper, sulphate plus water. Okay, here 2 NH4OH, and here this is 4, so 2 here, and water becomes 4 here. This compound is called tetraamine copper sulphate. Copper 2, because the valency of copper in this case is 2, sulphate, and it is a inky or deep blue solution. This is very, very important because the word solution is important. Here it is precipitate that dissolves to form a solution. So that we should have in mind. Okay. Now let us see this copper sulphate with sodium hydroxide first. This is copper sulphate solution. Okay. Now when I add sodium hydroxide to this, get a pale blue precipitate, and when I add it in excess also, the precipitate continues to be there. It does not dissolve. This is with NaOH. Now if I take the same copper sulphate solution, okay, and I add ammonium hydroxide solution to this, get a pale blue precipitate, and as I start adding more, see the precipitate starts dissolving and you get a dark blue solution. See, the precipitate dissolves. The particles are dissolving slowly and you get a deep blue solution. Okay, so these are the different color changes that we get with the different salts. So to recap, you have a pale blue precipitate here with copper, reddish brown precipitate with ferric, that is Fe3 plus, gelatinous white with zinc, chalky white with lead, and a dirty green precipitate with ferrous. Okay, I hope you enjoyed this.